section 1, we're going to talk about how to determine if our function represents exponential growth or decay. We're going to talk about how to use the e value, how to use compound interest, how to convert exponentials to logs, convert logs to exponentials, and evaluate a log function. So the first part of section 1, we have to determine whether or not our function represents exponential growth or decay. So over here to the side, I've written a few notes. In order to have growth or decay, a has to be greater than 0. So in each one of my functions, a is the value out front, b is the value that carries the exponent. So if I write the generic form of an exponential function, it's a times b raised to the x. So the b value is always going to carry the exponent. So in number 1, my a value is greater than 0. My b value is greater than 1, so that tells me that this function represents an exponential growth problem. In problem number 2, a is greater than 0, b is greater than 1, so it also represents exponential growth. In problem number 3, my value is between 0 and 1. So therefore, that represents exponential decay. Next, we're going to talk about our function that we use when we talk about exponential functions, such as a word problem. Then we can use this formula here. Now, you can also use this formula written a little bit different. So this formula here is for growth. I could also use the decay version of this formula, which looks like this. So, decay has a minus, growth has a plus. The a value is going to be my initial amount. R stands for my rate, and T stands for time. Initial means the amount that I started with. So these are two options that you can use for exponential growth or exponential decay functions based on the information that's given to you in a word problem. Now, next underneath that, we have evaluating the value of e. Now, these are simple because I can use my calculator. So on your calculator, if you notice, you have this button here that says ln, but also in blue it says e to the x. So my first function says e to the third power. So I'm going to press second, ln, gives me e with an exponent, and I'm going to type in 3. Gives me a solution of 20.0855. Notice I cut mine off at the 4th decimal place, because in my instructions it said 4 decimal places. So for problem number 9, I'm going to do the same thing. I'm going to press second, ln, and then my exponent is 0.5, which gives me a solution of 1.6487. Then I'm going to do the same thing for the last problem. So second, and then ln, and then my exponent is -4, and I'm rounding to the 4 decimal places. So 0.0183. Now, this next equation here is used for exponential functions, but only when I see the words compounded continuously. So notice I have those highlighted. That is the only time I need to use this formula, in which we call the PERT formula, because it spells out the word PERT, P-E raised to the R-T. So the P is going to stand for my principal amount. Or my initial amount, my starting amount, whatever you want to call it. Okay, whatever makes most sense to you is fine. So whatever amount I start with goes in for P. R is my rate, which is a decimal. Okay, not a percent. So I need to change whatever rate's given to me as a decimal. And then T stands for time. So notice my values here are not a whole lot different from my equation that I had here. The main difference is that PERT is used when I have a compounded continuous interest. So now here's some examples of how we can use the PERT formula. So 14 and 15 both say to find the amounts in a compounded continuous account given the conditions. So I'm using my PERT formula. I don't know A, which is going to be my ending amount. However, I did start with 3,000. E is part of the problem. Now I need to change my rate, so I have to move my decimal 2 places to the left, and then my time is 4. So E raised to the 0.05 times 4. So now all I need to do is I need to type that in to my calculator. So 300, that's being multiplied with E raised to the 0.05 times 4, gives me a solution of $366.42. So now I'm going to do the same thing for problem 15. So my beginning amount was $650. E is a value, it's a number. I'm not plugging anything in for it. I'm just going to use the function on my calculator. My rate needs to be changed to a decimal, so I'm going to move the decimal 2 places to the left. So that becomes an exponent, 0.065 times 20. So in my calculator, all I'm going to do is put in that value. So 650 times E raised to the 0.065 times 20. Notice that in my calculator, all of this went together. This is an exponent. So my solution for A is $2,385.04. We're dealing with money, so you need to make sure that you end this with 2 decimal places to hold the place value for the change. Now the last thing we talked about in section 1 is how to write equations in log form. Now when I'm writing my equation in log form, notice it wants log form, so I need to have log in my answer. So now I'm going to rewrite this so that the exponent piece comes first, and I'm going to use my circle rule to solve. So 2 becomes my base of 32 is now equal to 5. So I'm going to rewrite this. 3 to the 5th is equal to 243. Now I can use my circle rule. Log has to be in my answer. 3 is a base, so it becomes a base here. Of 243 is equal to 5. So I'm going to do the same thing for 18. I want the exponent portion to come first before I use my circle rule. So log base 5 of 625 is equal to 4. Now the next part says to write each equation in exponential form. So I don't need log in my answer, I just need an exponential. I can still use my circle rule. So now 3 is my base, 2 is my exponent, is equal to 9. So 3 to the 2nd power is equal to 9. For problem number 20, 5 cubed is equal to 125. Now, if you think that maybe you have written this wrong, you can always check it. So 5 to the 3rd power does give me 125. So I have written that correctly. Then for the last one, 8 cubed is equal to 512. Now, for the last part here, it says to evaluate. So I should have a solution when I plug these in. So in order to solve these, I'm going to math, letter A, which gives me log base. So in my calculator, I'm going to math, down to letter A, and then I'm going to type in the function exactly as it is on my paper. So that's a base of 9. My value there is 27. So my solution is 1.5. So for problem 23, I'm going to math, down to letter A. My base is 8. My value is 256. So I can write this as 2.6 repeating, or I can press math to a fraction, which gives me a solution of 8/3. So you can write this either way is fine. It doesn't matter. You can see them as written as both. Then for my last value, I have log base 125 of 1 divided by 25. So notice again, I get a fraction. I'm going to press math to a fraction. So my answer is -2/3.